So I can record?
We are now recording. Yep.
Hi, this is the ETHOnline technical workshops. We're going to start out with Ben and Andre introducing the Gnosis protocol prize, and we'll be introducing the conditional tokens prize. So I'll let them take it away now.
Hello there. I'm Ben and Andre. We'll be talking today about the Gnosis protocol and how to integrate safe applications on top of it. We'll hopefully give some ideas for some safe apps that you can build, and there are some prizes available as well. Right. All right, so we'll start off with just describing the Gnosis protocol as a decentralized trading protocol. I'll give some motivation for the protocol itself, why we built it, what it's good for, and some motivation for what kind of safe apps that or hopefully some insights on what kind of safe apps that you can build on top of it, followed by an example safe app that we've already been working on, and maybe even a demo if there's some time. So first, we should talk about the Gnosis protocol and give some motivation for why we built it and what it has to offer. Number one is arbitrage freeness. This means that at least within the exchange protocol itself, there are no arbitrage, there is no possibility for arbitrage. This exchange is also front-running resistant or resistant to front-running, which we all know is a current problem in the Ethereum network. The way that we sort of get around the front running in this exchange protocol is that we collect orders over a 5-minute period, and all of those orders are considered and settled within a single batch. So it's sort of a batch auction. One thing that this exchange has to offer that other exchanges do not is that the surplus is distributed to the traders. This means that traders can place limit orders and specify their price, but it's also possible that they'll get a better price. And it's likely that they'll get a better price if they're just making small trades in comparison with large market makers.
Sorry, you're not sharing the right screen.
Oh, what?
Just share the stuff.
Yeah.
Sorry.
All right then. So, right, we've talked about arbitrage freeness, front running, and distributing surplus to the traders. So surplus, by definition for us, is just essentially anything more you get than what you asked for. So if you say you wanted to trade 100 tokens for 90 of something, you might wind up getting 95 instead of the 90 that you requested, and in that case, you have a surplus of 5. One other thing that the Gnosis protocol facilitates is liquidity for low volume tokens. And we do this by introducing something called ring trades. This means that, for example, if somebody wants to buy toothpaste for Bitcoin and somebody else wants to buy, I don't know, a toothbrush for toothpaste. I'm not sure I'm getting this right, but essentially, we can match trades that are not direct between two tokens. And we'll see this in the upcoming example of how the exchange mechanism works. As for motivation for the hackathon, what we would hope is that people will build some safe applications that improve usability and visibility, and hopefully give some insight for we intend on giving some insight for viable safe applications on Gnosis protocol. We've got some really good ideas in store here, and we'll see them very soon. So to give an introduction to the exchange mechanism, we're going to make the assumption that all of us know what an exchange is. And for the most part, the Gnosis protocol is a smart contract exchange in which people would deposit their funds into the smart contract and place orders on the smart contract. Those orders are then filled, but then if you want to collect your tokens to be holding them, you would have to then withdraw them from the exchange. So everything is sort of done at the level of the smart contract. So as we mentioned, Gnosis protocol introduces a fully permissionless trading mechanism. We've gone with this term rather than just fully decentralized because anyone can use this without signing up. All you need to have is an Ethereum address and you can start trading here. Another really important aspect that isn't exactly listed here is that we are not the operator of this exchange. Anyone can operate this exchange. All they need to do is look at all the open orders that exist in the current auction, and they can find a solution or match the trades and submit the solution to the smart contract themselves. In doing so, the solvers are entitled to a reward that is essentially the fees that are collected by the exchange. The exchange has a 0.1% fee, and the solvers are entitled to half the fees collected, while the other half of the fees are burned. So this trading mechanism has essentially three main components: ring trades, which we'll see in our example very soon. Batch auctions, this is already kind of described, the fact that we collect orders over a 5-minute period of time. This allows the order book to sort of overlap, so that essentially this is a way that you can avoid front running, unlike on Uniswap. Please reach out and ask some questions if you have if you'd like to hear any more detail on the batch auction aspect here. And furthermore, we have uniform clearing prices. This means that when an auction is settled, the prices for each token is determined, and everybody who has a matched trade gets that price, which is, of course, strictly better than or greater than or equal to the limit price that the order specified. So, in fact, the auction mechanism is essentially implemented as an optimization problem for competing solvers that the smart contract imposes. And the constraints of this optimization problem are that the limit prices for all of the orders are respected, and of course balances are respected. We have token conservation on all the tokens, meaning that the number of every single token that is sold is equal to the number of tokens that are bought. And finally, arbitrage freeness, which we've already sort of mentioned. This means that it's not possible that someone could have taken a path from one token to a different token that would result in them getting a better price than having bought that other token directly. Now, we've talked about the constraints of the optimization problem, but the sort of the objective function is also evaluated essentially as utility. However, we discourage also disregarded utility. So the objective function really is the total sort of utility minus the disregarded utility. Disregarded utility in the sense that if your order is not fully matched, whatever is untouched, the untouched part of your order is sort of a disregarded in a sense. So you should think of this as the fact that all of the orders on the exchange are considered as sell orders, meaning that placing an order says you would like to sell all of what you have for at least as much of what you're requesting. Now, assuming that it's a sell order, this means that you sort of value selling all of what you have. And so this is what the disregarded utility means. So here's the promised example. I think this is the simplest example that sort of illustrates the exchange mechanism as a whole. If we look at the bottom two orders between bananas and cucumbers, we have the sell 9 bananas for at least 10 cucumbers. This is sort of a market maker who is hoping to sort of has a lot of banana and is hoping to make a profit by buying cucumbers at a slightly larger margin if we assume all of these things are of equal value. We have someone who would like to sell their cucumbers, and they're basically saying, well, I'll sell 10 cucumbers for at least 5. And what they're basically saying is, I don't care, I just want bananas, and I've got 5 cucumbers, and I'll take whatever I can get. I mean, you could think of this as a market order because it seems to be significantly below the value that we see according to all the other orders. Now, if you look at these other 2 orders, each of them are willing to trade bananas for apples at 1-to-1 and apples for cucumbers at 1-to-1. Now, this collection of orders actually admits two different solutions. One of them here being solution one, in which selling the cucumbers and bananas are traded directly for each other. In this case, the person selling the cucumbers winds up getting 9, which is good for them. So they specified that they only wanted 5, but they wind up getting 9. In fact, another valid solution would really only give them the 5. However, that's not a very good solution because there's no utility. So a better solution in this case is getting the 9. So basically, the person selling cucumbers now has a sort of surplus of 4. They get 4 more than they asked for. However, there's actually a better solution here, where if we trade around in the ring, then essentially everyone trades at 1-to-1. And person here selling the cucumbers winds up getting 10. They get a surplus of 5. So essentially, the first solution submitter, this would be a valid solution, and the contract would allow this. However, there is a window of time for which solutions are accepted. And in this case, solution 2 comes in and the contract decides that this is better. And so this is the one that sort of wins the batch. So essentially, we're trying to sort of give the utility or the surplus to traders. And this mechanism is a fairly good way of doing that. So just want to talk about some existing tools that we have if you're going to start building on top of this stuff. Of course, we have the front end trading interface. Nothing to build here, but at least a place where you can interact with the exchange. You've got trader page where you can place orders, and balance page. Anyway, this is more for just interacting with the exchange if you're interested. We've got a Telegram order bot. This is a place where if you're interested in seeing what kinds of orders are, okay, I can't see this. So this is a channel where you can see, oh no. This is a channel where you can see all the orders that are coming in and follow a link if you'd like to match them. All right, so these are basically just tools that you can use if you're interested in sort of just playing around with the exchange. Of course, there are a ton of GitHub repos. There's the web interface, which we've already sort of taken a quick look at. Liquidity provision. This is sort of built on top of the smart contract exchange. And this is where you can deploy trading strategies. These trading strategies are something we're definitely going to look into as a prime example for safe applications in just a few minutes. And this repo contains all the logic for that. The smart contracts is, in a sense, the heart of the exchange. This is the repo containing the exchange, the Gnosis protocol contracts, and a few sort of elementary scripts for interacting with the exchange through the terminal. The open solver, this is sort of something that you can run yourself if you decide you want to be a solver. Solvers can sort of earn fees for providing solutions. Solving batches in a sense, so we've already discussed. However, keep in mind, if you plan on running an open solver, there are gas costs incurred for submitting a solution, and you would like to sort of keep in mind the economic viability, that is the cost, it's the amount of gas that it's going to cost you to submit a solution versus the number of fees that you're going to collect for having your solution accepted. Anyway, here's a place where you can sort of get started with an existing solver that's already well integrated with the exchange. We have the CMM Safe app. This is something we're going to talk about in some detail later, so I'll save that for then. This here is the GitHub repo for the Telegram bot that we did not see here above, if you're interested in playing with that. Now, this section is really good, developer tutorials. There is this link here is all the developer tutorials that are available. Submitting an order, submitting multiple orders, setting up a custom market maker, adding tokens to the exchange. Remember, we mentioned this is a fully permissionless exchange. And that also means that if you have a token you want to sell, you can list your token right here on the Gnosis protocol, as easy as a 10-minute tutorial. Setting up Telegram notifications. This would be sort of working with the Telegram bot that we've discussed a little bit. Forking the Gnosis protocol web interface. This is very cool. A good use case that people have been using this for so far is to run their own IDOs. This means they would first follow the registering a token, get their token registered on the exchange protocol, and then they may want to fork the interface to sort of display an alternate interface where perhaps their token is the only token that can be purchased. Something like this. Integrations with the Gnosis protocol. This is a little bit more advanced, but the CMM brackets we're going to see soon are another good example of integrations with the protocol. For the most part, this tutorial will show you how to sort of pull the protocol contracts into your project as a truffle project and maybe pull in another exchange. I believe there's a demo in this tutorial that shows you how to write a bot that mirrors liquidity between two different exchanges, in particular, the Synthetics exchange. So it mirrors the liquidity between Synthetics and the Gnosis protocol. By doing this, a simple change to the existing tutorial, you could probably also write an arbitrage bot of some sort with the content of this tutorial between the Gnosis protocol and another exchange. There's another slightly more advanced tutorial for running a solver if you decide this is something you'd like to do. And let's get back to the slides here. Fork the UI, run a solver, and contract integration. These are the three sort of, I think, developer heavy tutorials that are available. And of course, for additional infrastructure, we also have all the events sort of archived in the graph, which can be seen here as well. The Gnosis protocol subgraph. So what we've all been waiting for, some really cool safe app ideas. I'm gonna list them in this order. They're sort of in order of simplicity. All of them are really cool ideas, and they sort of increase in complexity. So the IDO facilitator or order launcher, this would be a nice place to start because it only requires sort of elementary contract interactions. That means you can sort of work with the NPM module that is Dex contracts repo and the scripts that are contained within it for elementary interactions such as deposits, order placement, withdraw. So in IDOs, you would list your token and then you would like to sort of sell your token at perhaps incrementing prices. So as the demand comes in, you can sort of sell your token at varying prices. Or so, I mean, a safe app here would just be to have a nice interface where you can configure the way you want your orders to be placed and provide the liquidity. So do the deposit and place your orders. You should be able to also place your orders to be valid from certain periods and valid till certain periods. And so, yeah, nice place to start because it only really involves interacting directly with the contracts as a safe app. Now, another really cool idea that I'm quite fond of here is the stable token pooling interface. So this would require writing an additional smart contract on top of interacting with the contracts repo themselves. This contract is formally specified here. We could take a quick peek at what we've got here. Just to say, I believe there are several different components: indefinite order pooling, stable token pooling. So there's a whole section on stable token pooling here. And this would essentially be a contract in which people could, a contract that already has its orders placed on the exchange, in which people could simply deposit funds into this pool and be allocated a certain number of shares so that at the time they'd incur the fees that are incurred by placing small spread orders between stable tokens. Say there's a pool that is exchanging any one stable token for any other stable token at a rate of 1% above market price. So as stable tokens trade each other, you sort of, the pool incurs fees, and at the time that you withdraw, you would simply get your initial deposits plus any fees that may have been incurred that you're entitled to. So all the mathematics is here, and other specifications about how it should work, deposits, withdrawals, share allocation, etc. So it's all pretty much spec'd out, which is quite nice. Yes, slightly more advanced than the IDO facilitator. Right, another possible idea that's not necessarily as well adapted to being a safe app, but an arbitrage bot. This would be to follow the tutorial on integrating with the protocol itself, and sort of would additionally require some off-chain services. What just happened there? Would additionally require off-chain services, sort of to run a job every batch and see if there are arbitrage opportunities and place the appropriate orders in order to take the arbitrage. So not as well adapted to being a safe app, but still a pretty interesting idea that is already somewhat spec'd out in the integrations tutorial. Another possible option here is the simple swap. Right now, there are a number of transactions that the user is required to do in order to make a trade on the protocol. That means they would have to sort of approve the contract for transferring funds into itself, approve, followed by deposit, followed by an order placement. And then after the order has been matched, there's a request to withdraw, followed by a claim of a withdrawal after 5 minutes. So with this gelato project that sort of has some automation features, this linked here, you could perhaps sort of batch together actually this could be done with the safe alone, because we have you can batch transactions. In a sense, you could approve, deposit, place orders all in a single transaction. And then, I mean, you could use the gelato to then sort of execute the request and claim of the withdrawal after the trades have been placed. You can do conditional transactions with this gelato project. So here are some really cool ideas for safe apps, and not to mention one that we've already put in motion, the custom market makers. So trading brackets on Gnosis protocol. And this is where things get really exciting. So what everybody wants to do is buy low and sell high. Now, what you want to try to do is to capture the volatility of your favorite ERC20 tokens automatically. We're going to use ETH and DAI as our example here to describe how these trading brackets work. And what you can do with these CMM brackets is to trade across a range of different prices with very little EVM interaction after deployment. And we will see later when we address current issues with the Gnosis protocol that EVM interactions, the number of EVM interactions can be quite costly, especially with current gas prices. So what we have here is a graph of the price of ETH with respect to DAI over a period of time. We can see that it fluctuates a lot, and you know what people want to do, they want to buy low and sell high. So these brackets, what they enable you to do is they enable you to place orders and trade at multiple different prices over a range. So all of these different components here, we have several different trader accounts, each of them having a buy order and a sell order. They're buying ETH when it's low and they're selling ETH when it's high in this example. Now, what we do is we initially fund the bottom 4 trading accounts with DAI, and we initially fund the top 4 trading accounts with ETH. And the sort of center of this is the current market price. So in this case, we're saying, of course, this is not accurate, but we want to trade ETH above and below 10% of the current rate. So for example, in this diagram, account number 2, this one, is buying ETH at 92.5 and selling ETH at 95. Now, what happens if the price actually fluctuates in this way? Is that at this point, account number 5 sells the ETH that it has in this that it's holding at the price of 102.5. The price continues to go up and comes back down. At this point, usually account number 6 would want to buy ETH, but it's not currently holding ETH, or it doesn't have the DAI, it is currently holding ETH. So nothing actually happens here. But when the price comes back down to here, this account 5 is ready to buy ETH for 100, and it has the DAI to do so. We come back around again. Same thing kind of happens as before. Account number 4 would like to sell ETH, but it's currently not holding it. Once we go back up here, we continue this trend. Account number 5 sells at 102. Account number 6 sells at 105. Account number 7 sells at 107. We come back around. We're not holding the things that we would usually buy at this price, but we're not holding what we need to do so. Price comes way back down here, and we continue to buy as it goes way down. So what we're doing in a sense is always buying the undervalued token, but capturing the volatility. So a couple of things can happen here. If the price goes way up outside the range of your trading, then you'll be left with the lower valued token and you'll suffer impermanent loss. Same thing holds if the price falls outside your range at the bottom, you'll just be holding the lower value token. So by deploying a trading strategy of this sort, what you're saying is that I believe the price will lie within this range for an extended period of time. So this trading strategy can be deployed as easy as 1, 2, 3. What you do, I should describe this. We deploy a fleet of safes, AKA the trader accounts that we saw in the diagram, from a safe known as the fund account. The multiple trader accounts are required in order to properly partition the funds according to their orders. This means, of course, if you had placed all of these orders with a single account, then at all these different prices, of course, you'll always get the order that is the worst one that you placed, rather than actually filling your orders at multiple prices. So you have to sort of partition the funds across all the different accounts that have the volume to trade at different prices. The next operation that is performed here is placing unlimited orders on behalf of each of these trader accounts, each of them buying and selling ETH for DAI at the prices indicated in the diagram. Finally, after you've deployed your fleet of safes, placed all of your orders, you're in place to fund the accounts. You distribute the ETH and the DAI to the target above and below the target value that you've specified, and away you go. So it looks like as easy as 1, 2, 3, when really it is the safe that facilitates such complicated transactions. Because here, placing orders is placing orders on behalf of these different trader accounts. And this can only really be done from a safe, which can execute a batch of transactions and delegate the order placement to each of the sub accounts. Same goes for the funding of the accounts. What you do is you batch together all of the approvals on behalf of each of the trader accounts, and then all of the deposits. These amount to transferring the funds from the main account into each of the sub accounts, and then calling the deposit functionality and sending the funds into the smart contract on behalf of each of these trader accounts. So this is quite an elaborate set of transactions that can actually all be done in a single Ethereum transaction, as we'll see later. Right, so we should talk about a few of the current issues. Some of them may have already come up in the discussion, but more or less our current issues, or the issues with the Gnosis protocol at this time, are gas prices. For two reasons. We have the economic viability of the solver. So currently, in order for a solver to be profitable, or or to even break even, the sort of minimum sell volume to match an order for the fees collected would be about $2,500. Of course, this changes, this fluctuates with the prices of gas, but as we've seen in the last couple of weeks with gas skyrocketing, it's gotten even as high as 10K per order. So these are quite large volume trades. And so this is kind of an issue. Some of the things that we've talked about already, like pooling contracts, would help with this issue. So rather than having a whole bunch of people placing these stable token to stable token, like sort of spread orders that buy and sell stable tokens for like a marginal fee, and then the solver or the orders, we can only actually match 30 orders per batch. This is due to gas limits, block gas limits. The exchange mechanism only allows to trade at most match 30 orders in a single batch. However, if all of these orders were a bunch of stable token to stable token swaps, then a lot of the batch is being occupied and there's more gas fees incurred by matching all of these trades. If we had a pooling contract, for example, then matching a stable token swap would just be, that would only occupy one slot in the orders that can be touched. This would reduce the gas for submitting a solution and reduce the gas costs also incurred by the user, which we're going to talk about right now. Right now, a user would need to approve the contract, deposit, and place orders. So once again, with the stable token order placement, this means placing an order between, say, n different stable tokens, 5. You have to have a buy and a sell order back and forth between all of these different stable tokens. And that order placement alone is quite expensive. Wouldn't it be nice if there was a smart contract pool which has already placed those orders? These are unlimited, indefinite orders, so that the user can simply deposit directly into this pool, not have to place the orders, and all they would need to do at exit time is to request and claim the withdrawals. So gas savings for everyone all around. And like we mentioned as well, there are a lot of gas prices incurred just from interacting with the exchange, which sort of makes it like difficult to interact with. If you wanted to do an arbitrage trade right now between Uniswap or Synthetics and the Gnosis protocol, you would have to follow all these steps, approve the contract, deposit, place your orders, request and claim your withdrawals, and then go over to another exchange. So we have some potential solutions that are underway. Recently, we've been working on launching the Gnosis protocol on XDAI. In fact, the contracts themselves are available already right here. The front end is coming. This is a place where for low gas fees, you can interact with the exchange, buy and sell tokens, and build. Of course, pooling contracts, as we've already mentioned, would reduce the user's gas costs and make trades more economically viable. So I believe now we've got time to see Andre show us about the CMM Safe app.
Yes, thank you, Ben. So I'm going to showcase some of the CMM, not specifically the application itself, but more kind of like the process that we took in order to build this application and to build upon the Gnosis Safe and the Gnosis protocol at the same time. So just for context, I'll show some screenshots of the application that are currently building. You can see here, this kind of shows the deployment screen that we use in order to deploy a so-called strategy. The strategies is what we call the custom market makers. When they're deployed, we call them strategies. You can see here, you can select your tokens, the A token and the B token. You specify the price range that you want to use, the lowest price where you want to trade, the highest price where you want to trade, and the sort of like middle starting price. Then you can decide how many brackets you want and how much funding to put on each side of the tokens. This also has one more screen. This shows the strategies that are currently in place by your safe, even if you share it with multiple people. And it showcases the strategies, how much funding is in each, and which trades occurred. I'm just showing this for context before I talk about the kind of like tool chain that we use to build this, because it's a good point to get started on like building upon GP, and also, yeah, just to build a safe app. So I'll talk about the tool chain that we use for this, and I'll talk about all these points individually. But there is the DEX liquidity provision scripts, which Ben mentioned previously, briefly. The DEX contracts themselves, which includes the smart contracts and some utility functions and helper functions, a template to create new safe apps, and the so-called transaction service, which I'll also talk about. So the DEX liquidity provision was a good place to get started with GP in general for us. It's also a super useful tool chain just to debug issues that you might have when launching something on GP. So on the right side here, you can see the balance viewer script that is part of the DEX liquidity provision. And I just added all the brackets from one strategy that was deployed here, and it showcases me all the balances for each of those brackets, so I can see how the strategy is doing. I sort of consider this like a use case API for interfacing with the DEX contracts, because this implements basically the CMM principle upon them. So it's a good place to check out how to use the DEX contracts in a meaningful way. It uses truffle contract and Web3, so it was really easy for us to use this because everything uses truffle contract and everything uses Web3. Which brings me to the DEX contracts. They are the underlying foundation of this. The repository includes the smart contracts, but they also were kind enough to add like a lot of different utility functions, helper functions, and like really low level things to help you figure out how specific order is currently doing and how it all works. This really helped me figure out how to successfully work with Gnosis protocol. The repository also includes a minimal implementation example, which I thought was useful to just figure out how to quickly get started with the boilerplate, so to say, on the Gnosis protocol. Then there's the template safe app to get started on safe apps, so to say. The safe team probably already talked about this. It's based on create React app. So if you're used to creating React app, this is super easy to use. This actually wasn't used for the CMM, but I just found out about this, but it's very cool. It includes the boilerplate for the safe apps and the standard create React app. So the boilerplate for the safe app includes the generation of a manifest file. This includes the name and the app, the app icon and stuff like that. So you can see here on the right, this is the screen that is shown when you add a new app to your Gnosis safe. And yeah, the functionality to display like the name and the icon and all that, it's included in this boilerplate, which was super useful. The Safe App SDK is also used here, and it's already included. And that allows you to just interface with the Gnosis Safe itself when you're implementing it as a Gnosis Safe app. Then one more thing that is used in the boilerplate is the Safe React components. They are based upon Material UI, so pretty much a lot of developers can immediately pick this up because a lot of them have already worked with Material UI, which was really useful. And the Safe React components also include really nice documentation done using Storybook. So you can just check out all the different components and yeah, it's super easy to work with. And it's especially nice that it's a Create React app, which I think a lot of people have used in the past. And finally, the transaction service, which I thought was incredibly useful for building safe apps, because this not only allows you to access pending transactions, which is a bit iffy with the safe, because the safe doesn't immediately put a pending transaction on the blockchain. So you can't access it like the normal way you would, where you get the pending transactions. But they offer a web API instead. But this web API is in many cases even better than using Web3 functionality directly. For once, it automatically decodes ABI for a lot of contracts already. So you immediately see what the transaction is doing, and you can also programmatically see through it, look through it, and see what kind of interactions it's done with the various parts of the contracts. And this way you can just super quickly and efficiently build new applications. It also allows you to showcase things like how many signers are still needed in a multisig, and to showcase the various methods that are called, the people that already signed, the people that have rejected. So it was very useful for this. But also for the executed transaction, it also gives you all this ABI decoding stuff, which is so amazing, because then you don't have to worry about decoding it yourself, which can be a hassle with Web3 sometimes. So the link here at the bottom is actually the documentation for spinning this up yourself. This can be useful if you have various other contracts where you want the same functionality of the automatic ABI decoding. So I included it here. It's relatively straightforward to spin this up yourself. But for most cases, the links that are included in the previous slides, they include both the Rinkeby and the mainnet URL for the transaction service. So you can just use this to get started. And I hope that gave you a good first introduction on how to build something with Gnosis protocol and with the Gnosis Safe. Maybe a good place to figure out what kind of like project you can realize for the hackathon. And yeah, that's it. Thank you for watching. And if you have any questions, feel free to contact us on chat.gnosis.io. We'll be available for questions and helping people out. And yeah.
Happy hacking.
Happy hacking.
Well, thank you guys. Are there any questions?
You're welcome.
Okay, so we'll keep this link open for the next 15 minutes as we wait for the next presenters. So
It
yeah,
looks like we've got a question from
thanks so
Kata.
much for this informative. Yeah.
Sorry, I just wanted to clap instead of raising the hand.
Okay. Well, we see
Thank you.
that Amine is excited and will get in touch with us on Discord.
Yeah,
If
perfect.
there's any questions that you have, please reach out to us. We're happy to help. And we've got a lot of experience building on Gnosis protocol already. So please reach out.
Yeah, cool. Thank you.
Cool. Thanks, guys.
Thank you.
Thank you. You're welcome.
Bye-bye.
Bye.